Good day, everyone. This is ENS161, Statics of Rigid Bodies, Module 2, Statics of a Particle. Welcome to the second module of this course. So for this lesson, we will be studying the effect of one or more forces acting on a particle or particles. Specifically, by the end of this module, you should be able to first replace two or more forces acting on a given particle by single force or finding its resultant, solve a force into its components, understand the equilibrium of a particle, and create free body diagram in solving engineering problems. So the use of the word particle, which is acted upon by several forces, does not imply that our study will be limited of that of small molecules or small particles. But what it means is that the size and shape of the bodies under consideration will not significantly affect the solution of the problems treated in this module. So given that all the forces for acting on a given body will be assumed to be applied at the same point. So size and shape will not affect the solution of rigid bodies problems as long as the forces are applied at the same given point. So the first part, or in this chapter, we will devote our study on forces containing or contained in a single plane, meaning 2D, two-dimensional na plane yung perspective natin. Okay, so from the previous module, we know that a force represents the action of one body on another and is generally characterized by its point of application, magnitude, and direction. Forces acting on a given particle, however, have the same point of application. So, the magnitude of a force is characterized by a certain number of units. So in our case, we'll be using mostly SI units, which is Newton and kilonewton. And the direction of a force is defined by the line of action and its sense. So when you say line of action, it is an infinite straight line along which the force acts. So it is characterized also by an angle it forms with some fixed axis. So merong angle, for example, kung hindi siya horizontal or totally vertical yung direction or line of action ng force. So finally, the sense of the force should be indicated by an arrowhead. So meron siyang sa mga problems, we use an arrow to that represents yung force. So it is important in defining the force to indicate its sense. So two forces having the same magnitude and the same line of action but different sense, such as these figures. So on figure A, 10-pound force away from particle A at an angle 30 degrees with respect to the horizontal or say x-axis, and sa figure B naman is 10 pound toward A at an angle 30 degrees with respect to x-axis. So the only difference between the two forces acting on this particle A is the sense of the force. So with that said, the effect will be totally opposite yung effect nila. Okay, so experimental evidence shows that two forces such as P and Q acting on a particle A can be replaced by a single force R, which has the same effect on the particle. So this force is called the resultant. So it is a single force which has the same effect on a particle. So for example, yung A natin. So you can obtain resultant by constructing a parallelogram using P and Q as two adjacent sides of the parallelogram. So Q here and equivalent length ng Q dito and also yung P. So this makes a parallelogram. So the diagonal that passes through A represents the resultant. So if you are to create a parallelogram na ganito, so yung from point A, passing point A to the other corner of the parallelogram, yun yung resultant ng P and Q. So this method of finding a resultant is also known as the parallelogram law for the addition of two forces. So from the previous module, so na-mention natin yung parallelogram law. So this is only applicable if merong two forces. So if there are several concurrent forces, say 3, 4 forces, meron ding other methods in finding the resultant of that forces. Okay, so we have seen that two or more forces acting on a particle may be replaced by a single force which has the same effect on that particle, which is the resultant. So conversely, a single force F acting on a particle may be replaced by two or more forces which together have the same effect on the particle. So these components are called these forces are called the components. So say you have force F here acting on a particle A. So the component could be QP in this manner and also in this manner. So these forces are called again the components of the original force F. And the process of substituting them for F is called resolving force into components. So clearly, as what we have seen in these two figures, for each force F, there exists an infinite number of possible sets of components. So there could be many combinations or sets ng components ng force F. So, but in many problems, it will be found desirable to solve a force into two components which are perpendicular to each other. So, in this type of creating a components of a force, merong angle, so mas madali siyang ma-solve yung components mo kasi you can apply yung mga trigonometric functions natin. So, in the figure shown, the force F has been resolved into components Fx along x-axis and Fy along the y-axis. So, this is still the parallelogram law drawn to obtain the two components, which is a rectangle. So, rectangle is also a parallelogram. So, Fx and Fy are called the rectangular components. So, since we used the shape rectangle, so yung components are also called rectangular components. Okay, so using the trigonometric function, so familiar kayo sa SOHCAHTOA, no? So Fx is F cosine yung angle natin, and Fy is F sine yung angle natin, which is the opposite to the angle. So tangent theta or yung angle is equals to Fy over x, and also yung F is equals to the square root of Fx squared plus Fy squared. So this is from the identity that C squared is equals to A squared plus B squared yung triangle. So tinanggal natin yung square dito and ginawang square sa kabilang side ng equation. So in solving force into its rectangular components, we will be dealing with these formulas. So this is derived using yung trigonometric functions natin. So especially yung SOHCAHTOA. So you can look on that kung yung hindi familiar sa kung ano yung SOHCAHTOA. Okay, so there could be a case where the resultant of all the forces acting on a particle could be 0. So that means the particle is in equilibrium. So this is where yung statics of rigid bodies natin is yung concept ng rigid bodies natin. So the particle or the body applied with different forces is in equilibrium, meaning yung resultant or yung total effect ng different forces applied on that particle is zero. So say for example yung particle A natin. So sa particle A, which is acted upon by two forces, will be in equilibrium if the two forces have the same magnitude and the same line of action but opposite in sense. So from A, 100 pound going away from A, and also 100 pound going away from A on its opposite direction or opposite sense but with line of action and same magnitude. So the resultant of the two forces in this case will be then 0. So you can say that 100 minus 100, that would be 0. So we can say that A is in an equilibrium state or totally rigid state. Another case of equilibrium of a particle represented in this figure where four forces, so meron tayong F1, F2, F3, and F4, as shown is acting on particle A. So the resultant of the given forces is determined by the polygon rule. So since forces are more than 2, so hindi natin ma-apply yung parallelogram law or yung triangle rule. So we will use the polygon rule. So polygon rule, starting from O. So yung O, yung particle, say yung O is the particle. When arranging the forces in A, tip to tail. So meaning from the succeedance of the arrow is tip to tail siya. So hindi pwedeng mag-meet yung dalawang arrowhead. So that is yung polygon rule natin. So we find that the tip of F4 coincides with the starting point 0. So the F4 is bumalik din dun sa 0. So thus this means that the resultant of the given force system is 0 and the particle is in equilibrium. Kasi bumalik dun yung force, meaning the particle is rigid, or yung sum or yung total effect ng forces applied is 0. So say if this is a coordinate, so we have 300, 170, 200, and bumalik din dun sa origin or yung 0. So that implies that the closed polygon provides a graphical expression of the equilibrium A. So of the equilibrium of A. So to express this algebraically, so the conditions for the equilibrium of a particle, so we can write that R, our resultant, or the summation of the forces acting on a particle, is equal to 0. So resolving also the force into its components, we can conclude that the necessary and sufficient conditions for the equilibrium of a particle are. So we can also say that the summation of the x components of the forces is 0, and also the y components of all the forces is equal to 0. So ito in equilibrium naman, ito yung magiging conditions natin of the equation, or yung equations na gagamitin natin in the problems involving equilibrium of a particle. Okay, so in practice, a problem in engineering mechanics is derived from an actual physical situation. So a sketch showing the physical conditions of the problem is known as the space diagram. So for example, here we have a space diagram. So we have two guy which is holding a rope to carry a crate or a box using a pulley. So given the certain conditions, the angle and the weight of the crate, so we can solve the problem. The methods of analysis discussed in the preceding sections apply to a system of forces acting on a particle. So A large number of problems involving actual structures, however, can be reduced to problems concerning only the equilibrium of a particle. So this is done by choosing significant particle and drawing the separate diagram showing the particles and all the forces acting on it, such as the diagram. Such a diagram is called the free body diagram. So say the particle A, yung particle A natin, so we'll only consider BA, AC, and A yung crate natin. So hindi natin isasali yung dito na part kasi this is also equal sa BA. So ito yung sinasabi dito na choosing the significant particle and you separate it and you draw the free body diagram. So particle A is acted upon by forces TAB, TAC, and the weight of the crate. So using the polygon rule or force triangle, so in tip to tail manner, so ito yung tip to tail, no? So nag-close polygon siya, so meaning the forces is in equilibrium or yung resultant niya is 0. So given that the weight of the box is 75 kilogram, so from the previous module we learned that weight is equal to mass times the gravitational acceleration of the Earth. So that is 75 kilogram multiplied by 9.81 meter per second squared is 736 kilogram meter per second, or that is simply yung Newton natin. So by applying trigonometric functions or trigonometric solutions, so in this case you will use sine law. So sine law is the length or the length of this side over the sine of the opposite angle. So that is TAB over sine 60 is equal to TAC over sine 40 and also equal to 736 Newton or yung weight ng box over sine 80. So we only have two unknown equations, so we can solve by separating the equation ito using this part. So we can solve that TAC is equals to 480 Newton. Also yung itong part na to, we can solve that TAB is equals to 647 Newton. So this is sine law. So parang ano siya, parang standard na to na way of solution using triangles. So I hope you are familiar with sine law and also yung cosine law. Okay, so when a particle is in equilibrium under three forces, the problem can be solved by drawing a force triangle. So just like this example, so you can solve it using component method, but mas mabilis kung force triangle yung gagamitin natin. So ganitong manner ng solution. So mas mabilis siya compared sa i-component mo pa siya. Mas mabilis yung solution at maiksi yung solution. So all you have to do is to analyze it properly and to apply yung tip to tail fashion in arranging the succedence of the forces. So as long as nag-create ka ng triangle, so pwede mo ma-apply yung sine law or yung cosine law. So also when a particle is in equilibrium under more than three forces, the problem can be solved graphically by drawing a force polygon. So katulad yung previous na ano. So if an analytic solution is started, the equations of equilibrium is or it can be used. So four or three forces, equations of equilibrium can be used. So that is yung summation of forces equal to 0 and summation of the components is also equal to 0. So for forces or for a force system containing four or more forces, apply natin yung equations of equilibrium. So hindi na ma-apply yung force triangle. Okay, so for better understanding, let's have some sample problems. So the two forces P and Q act on bolt A. So determine the resultant of these forces. So applying the parallelogram law, so the force passing through A is the resultant with an angle alpha with respect to the horizontal or yung x-axis natin. Then, since we only have two forces, we can use the triangle rule in solving the resultant. So, first we will solve the angles na involved. So, from the figure given, it is given na this angle is 20 degrees. And also, this angle here is equals to 25 degrees. Ito yung angle na to. So, since this is a 180, so this is 180, this horizontal, so we can solve yung angle, interior angle natin dito. So, this is 180 minus 25, so that is 155 degrees yung angle natin dyan. Okay, so now that the two sides and the included angle are known, so P is 40 and Q is 60. So we can apply the law of cosine or yung cosine law. So finding R, so we can solve that R squared is equals to P squared plus Q squared minus 2PQ cosine yung angle natin between P and Q. So ito yung law of cosine. Okay, so meron tayong P, Q, and theta. So R squared is equals to P is 40 squared plus 60 squared minus 2 times 40 times 60 cosine of 155 degrees. So by solving the equation, we can solve that. R is equals to 97.73 Newton. So yan yung resultant natin using cosine law. Okay, so now applying the law of sine, we will solve yung alpha natin. So sine A, or the interior angle at A, over Q is equals to one of the known forces is sine 155 degrees. So dito na angle over the resultant. So we can solve this transferring Q sa kabilang equation. So sine A is equals to Q, or 60 Newton multiplied by sine 155 degrees over the and 7.73 Newton na resultant natin. So by finding A, ilipat natin yung sine or sine inverse sa kabila. So magiging sine inverse of 60 Newton multiplied by sine 155 degrees over 97.73 Newton. So leaving only yung A natin, or yung angle, interior angle at A, which is equals to 15.04 degrees. So hindi pa to yung alpha natin. So alpha, so from the figure, alpha is equals to angle at A plus 20 degrees. So meaning that is 15.04 degrees plus 20 degrees. So alpha is approximately 35 degrees with respect to the horizontal, or yung say x-axis natin. So in solving the resultant, it is important to also solve yung angle niya or yung direction niya. So parang pair na sila. So you can say that R, therefore, R is equals to 97.7 Newton at 35 degrees. Yan yung resultant natin. So for alternative solution, you can also solve this using yung components method. So pero compared to this equation, this solution mas mabilis siya i-solve using triangle rule. Okay, so let's have a problem considering more than 3 forces. So 4 forces act on a bolt A as shown. So determine the resultant of the forces on the bolt. So in this figure, in this case, this is as good as the free body diagram. Okay, so we have a particle A here acted upon by 4 different forces. So the convenient way in solving forces in its components and in finding its resultant is in a tabulated solution. So tatabulate natin yung force, yung magnitude, yung components niya. So say we have a table here. So meron tayong force 1, F1, F2, F3, and F4. So the magnitudes of these forces, so for F1, meron tayong 150 Newton. F2 is 80 Newton. And F3 is 110 Newton. F4 is 100 Newton. So for F1, yung X component niya is cosine yung gagamit natin. So ito yung angle ng F1. So X component niya is 150 cosine 30. Okay, so 150 cosine 30 is 129.9. So help me calculate. So 129.9, and Y component niya is 150 sine 30. Since yung Y component niya, so this is the Y component and this is the X component. So adjacent to the angle is X, so cosine 30 yung X component, and yung Y component is opposite to the angle. So that is sine. So 150 sine 30 degrees is positive. So we have to indicate yung sign niya since this is in a coordinate plane. So force 1, so Y is positive and X is positive. So positive 75.0 Newton. So F2, has a positive na Y and negative na X component since it is going sa kabilang direction. So okay, so in this case 20 degrees with respect to y-axis, so meaning yung X component niya is 80 multiplied by sine 20 degrees, so that is negative 27.4 Newton. So Y component niya is 80 cosine 20 degrees, so that is 75.2. So 80 cosine 20 is 75.2. So force 3, it is directly downward, so wala siyang X component, so this is 0, and Y component niya is as is yung 110 na magnitude, but negative yung sign niya since it is a downward force. So it is a standard convention that ito yung mga positive na signs natin. So aside from that, so dito yung negative X and negative Y. Okay, so force number 4 or fourth force, 100 Newton. So x component niya is 100 cosine 15 degrees. So that is positive 96.6 Newton. So y component naman niya is negative. So pointing downward. So that is 100 sine 15 degrees. So 100 sine 15 degrees is negative 25.9 Newton. So we will sum the x component and y component. So r x, so total, so that is positive. So 129.9 minus 127 plus 96, so that is positive 199.1 Newton. And yung y component natin is equals to 75 plus 75 minus 110 minus 25.9. So matitira lang is positive 14.3 Newton. So with the signs both positive, so meaning the resultant is somewhere in the first quadrant. So maybe if we estimate it, so konti lang yung y niya, so maybe yung resultant niya is somewhere dito. Ito yung magiging resultant at an angle theta. So that's important na malaman natin yung mga sign ng each component. Okay, so the magnitude r is equals to the square root of rx squared plus ry squared. So that is 199.1 squared plus 14.3 squared. So yung magnitude natin is equals to, so ilan yung magnitude natin? So that is 199.6 Newton. Okay, so now for the direction. So we have said that the resultant is located on the first quadrant since yung components is all positive. So ry is 14 and rx natin is 199. So say if we create a parallelogram, so ito yung magiging resultant natin. So this is r angle theta. So how do we solve the theta? So yung binigay natin na equation kanina, tangent theta is equals to, so ry over rx. Okay, so theta is equals to the tangent inverse of ry is 14.3, that is positive. So kailangan natin indicate yung sign when solving for the direction. So that is positive, also positive 199.1. So yung theta natin is equals to 4.1 degrees. So ito yung direction niya. So therefore, the resultant is equals to 199.6 Newton, theta 4.1 degrees. At 4.1 degrees. Okay, so that is how you solve force system more than 3 forces. So mas madali siya using component forces and tabulated yung solution mo. So hindi ka malilito sa pag-solve, no? Okay, so next problem. Okay, so in a ship unloading operation, a 3,500 pound automobile is supported by a cable. So that is, ito yung automobile. A rope is tied to the cable at A and pulled in order to center the automobile over its intended position. So, it is pulled by a man. So, siguro si Superman siguro to, no? Kasi mabigat man yung sasakyan. So, the angle between the cable and the vertical is 2 degrees. So, it is almost vertical. So, in this problem, so, it is alright na i-exaggerate natin yung angles. Kasi kung isa-follow mo ito na 2 degrees talaga, so medyo mahihirapan ka sa pag-solve, no? Kasi almost vertical na siya. So, while the angle between the rope and the horizontal is 30 degrees as shown. So, ito yung 30 degrees. So, what is the tension in the rope? Okay, so first we will draw the free body diagram. So, we will select A as the point of importance, so yung particle. So, say, this is A. First force is yung itong rope na to. So force, say TAB. So with respect to the dito, this is 2 degrees. And then the weight ng automobile, so that is directly downward, is 3,500 pounds. And rope TAC, so this is 30 degrees. So ito yung free body diagram natin. Okay, so since only three forces is acting on the body, so we can use the force triangle and to express that it is in equilibrium. So we'll use force triangle. Okay, so first is the this is the 3,500 pound na force. So in a tail to tail manner, so dito yung TAC. So ano yung TAC and ano yung TAB, ha? And then yung TAB natin. So that is tip to tail. This is TAB. So this is 2 degrees. 2 degrees. And this angle is also this angle. So that is 90 plus 30 degrees. So that is 120 degrees. The remaining angle would be 180 minus 120 minus 2 degrees, since the triangle has a total interior angles of 180 degrees. So yung angle natin dito is remaining angle is 58 degrees. Okay, so ito yung fourth triangle natin. So using law of sines, so we can say that TAB over sine, so opposite angle niya is 120 degrees, and 3,500 pound over 58 sine 58 degrees, and also sine TAC TAC is equals to over sine 2 degrees. Okay, so we are denoting force as T because yung rope natin is in tension, meaning the rope is subjected to tensile forces or nahihila siya. So if you have a particle here with forces na parang hinihila siya, that is in tension. Or particle naman is the forces toward that particle, so that is in compression. So in this problem, we can say that, or it is obvious na the ropes are in tension, no? Okay, so we have two unknowns with two equations. So first equation and second equation. So we can solve the tensions or force TAB and TAC. Okay, so first is solve natin yung TAB. So TAB is equals to sine 120. So ilipat natin to sa kabilang equation. Multiplied by 3,500 pounds over sine 58 degrees. Okay, so by the way, so since yung force natin is close siya ng closed polygon or closed triangle, meaning the resultant is equals to 0. Okay, so this is completely rigid or static na engineering problem. So TAB is then equal to 3,570 pounds. Okay, so now yung TAC naman. So TAC is equals to sine 2 degrees 3,500 pound over sine 58 degrees. So TAC is equals to 144 pounds. So 144 pound, ito yung kailangan exert na effort ni guy here, si Superman. So 144 pound is roughly around 70 kilograms, no? So malakas si Superman. Okay, so that's it for this. That's it for this problem. So to solve a problem on your own, so there are points that we should dapat na naintindihan na natin. First is when a particle is in equilibrium, the resultant must be 0. So yun yung condition ng equilibrium. The resultant must be 0, meaning summation of forces is equals to 0. And important note, drawing a free body diagram is the first step. So drawing a clear and accurate free body diagram is a must in the solution of any equilibrium problem. Kasi na-simplified na yung space diagram into the free body diagram, and mas madali natin maintindihan yung problem. So since we can only see yung forces and yung mga magnitude and yung direction ng forces, so that is how important yung free body diagram natin. Next is if in a case where there are only 3 forces involved, so you can use force triangle. So mas mabilis magsagot kung force triangle yung gagamitin natin. And in a case where more than 3 forces are involved, or yung 4 forces, katulad yung last problem natin, you can use an analytic solution by resolving each forces into its components. So ito yung mga dapat nating tandaan in solving static engineering problems. Problem. So given the figure, so from the figure, knowing that alpha is 20 degrees, so this alpha is 20 degrees, determine the tension at cable AC and tension at cable AB. So known yung merong weight na 120 pound dito na part. So I want you to pause this video and solve this problem yourself. So i-pause nyo muna and i-solve yung problem na to. Okay. So did you get it right? So by solving the problem using force triangle and by sine law, we have found out that the tension at rope AC is 1,244.20 pounds. So it is obvious kasi it is somehow directly below or opposite to the 1,200 pounds. So it is carrying more tension. And TBC is 115.40 pounds. So I hope you get it right. Okay, so for your assessment question, there are two cables that are tied together at C and are loaded as shown. So meron tayong dalawang situation. So situation A, meron two cable with attached at C with a 160 carrying 160 kilogram at C. And also dito na part, so your cables AC and BC are attached at C with a force away from C, which is 660 Newton. Okay, so question is, find or determine the tension at cable AC and tension at cable BC. So ano yung mga tension na to? AC, tension, BC, tension AC, and tension BC. So this is a two different situation but same or somehow similar yung pag-calculate ng solution niya. Okay, so I will post this assessment question for you to answer and to be submitted sa Google Classroom natin. Okay, so that's it for the module 1. So medyo mahaba-haba yung lecture, no, kasi sa mga sample problems. But I hope may natutunan kayo sa lecture video natin. So references. So that ends our module 2 and thank you for listening and have a good day.